we have studied about acid and base. Now, there should be something that will be used to measure the strength of acid or base. There is a scale which is known as pH scale. The pH scale starts from 1 and ends on 14, you can see in the scale. The 7 is the neutral state. The pH 7 is the neutral state. If the pH of a solution is less than 7, so it will be acidic solution, or if the pH is more than 7 up to 14, that will be basic solution. Now, the question is that how can we calculate the pH of the solution? There is a formula. There is a formula of pH, but before that formula, you have to remember that if in a question acid is given, so we can directly calculate the pH, and if a base is given in the numerical, we cannot calculate pH directly but indirectly. First of all, we have to calculate pOH from this formula, and when the pOH has been calculated, so then we can write the relation between pH and pOH to calculate the pH of the base. Now, for example, we have a numerical, calculate the pH of 0.001 molar acid or HCl. It may be acid directly, or it may be a name of specific acid such as HCl. First of all, make the data. You can see acid or HCl, that is 0.001 molar. Capital M stands for molarity or concentration. We have to calculate pH. First of all, we have to see the given solution is an acid or a base. You can see it is an acid. HCl is an acid. So we can calculate pH directly. Now, place the formula of pH, that is pH is equal to minus log H plus. Okay, it is the formula of pH. Now, place the value of HCl or acid or hydrogen in the bracket like this. You can see. Okay, now we have to convert the value in the exponent. We have to calculate the value in the exponent. You can see if we have the value 0.001, you can see there are 3 digits after point. You can see there are 3 digits after point. So we have to write 1 exponent minus 3. Exponent means multiply by 10. Okay. So after this, we have to apply the formula. We have to apply the formula. pH, we have to left minus over there. We have to left minus over there, and we have to apply log with both the value. There is a nature of log. That is, when the values are in multiplication, the log will add them. 1 and 10 are in multiply. 1 and 10 are in multiply. When we apply log, that multiply will be converted into plus. You can see minus log 1 multiply replaces with plus, and then power become the value before log. You can see minus 3 log 10. After this, remember log 1 always is equal to 0 and log 10 always equal to 1. Now place the value. Log 1 is equal to 0, then minus as it is log 10 is equal to 1. After this, you can see after this plus minus convert into minus, and 3 ones are 3. Then 0 minus 3 minus 3 minus and minus, that is already present outside the bracket. That minus is equal to plus 3. That is the pH of the solution. Now, you have to calculate this numerical by yourself easily. Just you have to change the concentration, you have to change the exponent only. Okay, take the screenshot of this and you have to solve it by yourself, and then you can take help from this video. After this, let's calculate a numerical in which base is given instead of an acid. You can see, calculate the pH of 0.001 molar sodium hydroxide, which is a base. So make the data. Base or sodium hydroxide is 0.001 molar NaOH. pH we have to calculate, but we know that for base we cannot calculate pH directly but indirectly. First we have to calculate pOH by the formula pOH बराबर minus log OH minus. Then write the value of sodium hydroxide in the bracket, make the exponent of it, make it exponent, and then the same procedure. Exponent, apply log, then 3 1s are 3, the same process, but here the POH is 3. Then we have to calculate the pH by the relation pH is equal to POH. pH plus POH is equal to 14. We have calculated POH, we have to place POH over there. Place POH plus 3, when move on the other side it will become minus 3. Then the pH of the base is 11. Similarly, the same numerical, just the value is changed. You have to solve it by yourself or you can take help by this video. I have calculated already. Okay students.